Hello, hi everyone. Welcome to our channel. Today we are going to start tutorial problems, chapter number 2, chapter number 52 from BL Theories Electrical Technology, volume 4, Electronic Devices and Circuits. So, in this case, we are moving to the problem number 1 in this particular video from tutorial 52.1. Find the current supplied, if any, by the battery in the circuit shown in the figure 52.49. So in this particular diagram, we can identify two diodes are connected anti-parallel, which uses two oppositely connected. Those diodes are ideal diodes. What is mean by ideal? Ideal is nothing but the internal resistance of the diodes is equal to 0. There is no internal resistance at all. Those call it as ideal diodes. So in this particular case, you need to find out the current. What is the answer is given? 1 ampere current. Once you are find out in the solutions. So just find out the solution first. D1 and D2. First D1 is connected to the positive here. D2 is D1 terminal is connected negative here. You know, diode have a two terminals. One of the terminal is anode, other terminal is a cathode. So anode is connected to the positive. So here cathode is connected to the positive and the anode is connected to the negative. In this particular case, anode is connected to the negative and cathode is connected to the positive. Diode D1 act as a open circuit, that is a off state. It won't allow any current. It is a reverse bias. After that, you know, this negative terminal is connected to the cathode and this positive terminal is connected to the anode, right? So in this particular case, diode act as a forward bias. So forward bias means on switch. These two conditions clearly, you know, these two conditions definitely can draw the equivalent circuit diagram for that. So here plus and minus, what is the voltage we are given? 18 volt. After that, you know, resistance is 6 ohm. Diode D1 is a off state, that is a open circuit. So once it is open circuit, there is no current flow into this particular branch. 3 ohm resistance is not affected to the circuit. Now here this particular diode act as a closed switch. It is a open switch, it is a closed switch. What is the resistance present here? 12 ohms. Okay, once you know this particular circuit, the current supplied by the battery is I. So find out the solution. You know, this 6 ohm and 12 ohm, the total entire current flowing through here, this 12 ohm resistance only, there is no current flowing here, 0 amperes. Once it is 0 amperes, the current is same current flowing through the 6 ohm as well as 12 ohm. Both the currents are same. It is called as a series combination. So once it is a series combination, R equivalent is equal to 6 plus 12, that is equal to 18 ohms. You know, once you got the 18 ohms is a resistance, you know, Ohm's law, I is equal to V by R equivalent. So V is a 12, 18, R is a 18, that is equal to 1 ampere. So what is the answer? We have already I mentioned in the answer 1 ampere. Okay, this is about the solution for the problem number 1. Thank you. Right everyone, let us start our next problem, problem number 2 from BL Theories Electrical Technology, volume 4, chapter number 52, tutorial 52.1, second problem. So what is the current supplied by the battery in figure 52.50 if diode D is ideal? So in the case diode is ideal, already mentioned, if it is ideal, there is no resistance, there is no internal resistance. Okay, so first this polarity is plus and minus because this is a DC supply. This plus is connected to the anode of diode and this negative is connected to the cathode of diode. Okay, once you know diode D is connected to anode is positive, cathode is negative, it is a on state. Okay, so it is a on, it is act as a on switch. Our equivalent circuit diagram will be plus and minus 12 volt, as well as here 4 ohms. Look at here. Diode D is a on switch, is nothing but it is a closed one. This is diode D. Here resistance 8 ohms. Okay, this is our circuit. We need to calculate this current I. So you need to understand, diode D is a closed means it is a short circuit. So here it is a short circuited. In case of it is a short circuited diode is ideal. What about the resistance here? 0 ohms. Already mentioned, in case of ideal diode, resistance is 0. So these two are connected in parallel. So R equivalent here 0 into 8 by 0 plus 8. R1 into R2 by R1 plus R2. That is a formula for parallel connection. So that will be equivalent to 0 ohms. So it is 0 ohms means this total entire branch is neglected. Our equivalent circuit diagram will be here 12 volt, here 4 ohms. This is our circuit, because this 8 ohms is neglected whenever it is a short circuited before branch, parallel branch. Now finally current I is equal to V by R. V by R. What is the V? 4 ohms. What is the R equivalent? V is at 12. R equivalent is 4. That is equal to 3 amperes. So what is the current now? 3 amperes. Okay, this is about the solution for problem number 2. Just verify the answer here. It is a 2 amperes. Okay, thank you. Hello, hi everyone. Welcome to our channel. Now we are moving to the problem number 3 from volume 4, electrical technology, electronics devices and circuit. That is a problem number 3 here. In figure 52.1, the signal voltage have a peak value of plus or minus 21 volt and its frequency is so high that reactance of a coupling capacitor can be neglected. Here, see here, this is a 31 millivolt. So the capacitance is neglected because of it. It is a very high frequency is present. That's why reactance is neglected. High that reactance of coupling capacitor is neglected. Next, if a bulk resistance of a silicon diode is neglected, what would be the approximate waveform of V0 across the diode? This is what problem. So this is a V0. You need to draw the waveform across this diode. So first of all, how many sources are present? 2 sources are present. If 2 sources are present, I am not directly calculate the V0 value. I can apply the superposition theorem. In case of superposition theorem, only one voltage source is acting alone, remaining all other sources are deactivated. So first of all, I am going to consider the DC case. So 30 voltage source acting alone and then remaining sources are deactivated. So first of all, I am going to DC equivalent. Okay. In case of DC equivalent, what would be the voltage source is present? Only 30 voltage source is present. Okay, 30 voltage source is present. Now, this source is short circuited. What about the capacitance? The capacitance in case of DC, it is to act as a open circuit. Whenever it is open circuit, total entire this portion is cut down from the circuit. So what about the portion is left for you? So diode portion is left, right? As well as here resistance will be there, that is a 30k, as well as next one the voltage is present, that voltage is 30 volt. It is connected to the ground. Okay, this is what we have the circuit. Now this is the voltage across this silicon diode. What amount of voltage is present? 30. So that is equal to it is a silicon diode. So the voltage across this diode is V0. Okay, this is a V0. Is it okay? So that V0 I can know, the V0 value directly, V0 is equal to 0.7 DC. Okay, the first portion is done. What about the voltage? Once you are giving this particular circuit, your DC voltage, the waveform is 0.7 DC. Okay, fine. Next, second case. The second case, AC equivalent. AC equivalent. In case of AC equivalent, what about DC is a short circuited, right? So our equivalent circuit diagram will be, just see the diagram here. This is the AC. This is the AC. That will be plus 21 millivolt. So 1 kilo ohm. The problem itself, capacitance is neglected, right? So it is not considered in case of AC for higher frequencies. And we have a resistance, this 30k connected parallel, 30 kilo ohms, as well as this diode is present, right? The diode resistance you want. You don't know that diode resistance, I will explain. This is the resistance, the voltage across this diode is V0. Okay, so just go through the problem once. It is mentioned that bulk resistance of a diode, silicon diode, is neglected. So in case of AC, the resistance RAC is equal to RJ plus RB. This bulk resistance is neglected. So what amount of resistance is present? That is a RJ. For silicon, it is a 50 millivolt by 1 milliampere. That will be equivalent to 50 ohms. It is a constant for silicon, irrespective of the input voltages are present. I hope that it is clear. What about in place of resistance? In place of diode, I can write it here 50 ohms. So once you got the 50 ohm resistance, this voltage you want. This is a 21 millivolt you can apply. Apply that voltage division rule. Before that, find out the equivalent resistance for these two combination. So the equivalent resistance will be 30,000 into 50 divided by 30,000 plus 50. That will be equivalent to 49.91 approximately, equivalent to 50 ohms. So finally our circuit will be here plus 21 millivolt, here 1k is present, and here only 50 ohms is present. Okay, here voltage V0. So once this is the equivalent circuit we have. So you can find out V0 value now. So how to find out V0 value? By applying the voltage division rule. V0 is equal to total supply voltage plus or minus 21 into 10 power minus 3 into voltage division rule means same resistance 50 divided by total resistance 1000 plus 50. So that will be equivalent to approximately 0.999 millivolt, approximately equivalent to 1 millivolt. Okay, this is what we got from the AC. Okay, so finally I have a DC voltage of 0.7 volt and AC voltage of 1 milliampere plus or minus 1 millivolt. This is a voltages. So in the problem we have to draw the waveform across the diode, right? So this is a reference. So the voltage waveform in case of DC, it is a 0.7, right? So it is a 0.7 volt if you are applying the DC. Now in case of AC, what about the voltage? In the case of AC, after shifted 0.7, this is the voltage waveform. So the value here plus or minus 1 millivolt, here minus 1 millivolt. This is what we have. Okay, this is for DC, this is for AC. This is the output voltage V0. Okay, this is about the voltage waveform across silicon diode. Okay, I hope that everyone is enjoying the class. If you want all the solution for volume 4 in our mobile app, the all chapters unsolved problems going to be provided for you. If you want, you can go and subscribe our course. Thank you. Hello, hi everyone, welcome to our channel. Problem number 4 from electrical technology, volume 4 textbook. Okay, this is the textbook I am following. Electronic devices and circuits, electrical technology, volume 4. I am going to provide the all chapters unsolved problems from this textbook. If you want, you can go to our mobile Play Store, you can purchase it. So link available in our description. Okay, let's start our question. Sketch the voltage across RL in the clipper circuit. You know, clipper and clamper. Clipper is nothing but a, for example, AC voltage is available, some part of the portion will be clipped, that is called as a clipper. If you are giving AC supply, the positive half cycle you don't want, you want to clip the positive half cycle, you can do that with the help of the using clipper. So in this particular circuit, sketch the voltage across RL. Where is RL? RL, this one is RL, voltage across RL in the clipper circuit. So it is a very easy, just understand, listen. Here it is a AC voltage waveform, right? The peak value is a AC voltage waveform. First of all, I am going to consider positive half cycle. In case of AC, we have a positive and negative half cycle. Positive half cycle. So in case of positive half cycle, our equivalent circuit diagram, I am going to draw the equivalent circuit diagram for positive half cycle. This is a positive. The voltage value is given plus 10 volt in case of positive case. Okay, resistance is 1 ohm, it is present, as well as in case of positive half cycle, just look at here. In case of positive half cycle, this is a positive, this one is a negative. That means anode is connected to positive, cathode is connected to negative. So whenever anode is connected to positive, cathode is connected to negative, it is a on state, it is a closed switch. Because I am going to consider diode is ideal, it is a closed switch. Fine. Next one. Of course, it is a closed switch. But what about it is a silicon, right? In case of silicon, what about the voltage? Is 0.7. Voltage is 0.7 volt. This point is very important. I can replace the diode is a forward bias diode replaced by 0.7 because that is a silicon diode. So here resistance is 1 kilo ohm. That is a RL. RL is equal to 1 kilo ohm. Now you want to find out voltage across RL, right? That is a VL is equal to, it is a connected in parallel, both are connected in parallel. The voltage is 0.7 volt only in the positive half cycle. I got positive half cycle voltage is 0.7 volt, constant value, DC value I got. Next we are moving to the negative half cycle. Negative half cycle. So in case of negative half cycle, before going to the negative half cycle, just see here, it is a 0.7 volt output waveform. Like I am going to draw the complete waveform later, just your understanding purpose. Only 0.7 volts only it is allowed. Okay, it is allowed up to 0.7. After that it is a constant and then positive half cycle is completed. It is a 0.7. What about the portion is clipped? This portion is clipping. This portion is eliminated, right? Next one, negative half cycle. In case of negative half cycle, see, this is a minus 10 10 or 12 volt, 10 volt. Okay. Next one, resistance. It is a resistance 1 ohm. In just again understand, just again look at the circuit. In case of negative half cycle, here anode is connected to negative, cathode is connected to positive. In case of negative half cycle, the polarities are reversed. Negative is connected to anode and positive is connected to cathode. In that case, diode is a reverse bias. Whenever diode is a reverse bias, they act as a open switch. Ideally, there is no resistance. So we have a load resistance. That load resistance will be RL is equal to, what about load resistance? 1 kilo ohm. Okay. So now V0 is equal to 10 into, of course, minus 10 into voltage division rule. I want to find out the voltage across RL, that is a VL I want. So VL, total voltage into same resistance 1 kilo ohm, that is 1000 divided by 1001, that will be equivalent to 9.99 volt. It is approximately equivalent to 10 volt. So I got positive half cycle as well as negative half cycle. I am going to draw the equivalent circuit now. I am going to draw the waveform across load resistance. So here, the first of all, the input is AC. This is a waveform of input. Next, output I want, right? So output waveform, in case of positive half cycle, in case of positive half cycle, it is conduct up to here, it is a clipped. In case of negative half cycle, what amount of voltage present in the input? 10 volt, right? This 10 volt present across this 10k. There is no clipping in the negative half cycle. Negative half cycle as it is there. Again, it is a clipped positive. Again, negative half cycle is present. This is the output waveform V0. So here, what about the portion is clipped? This is a portion is clipping. This portion is clipping. Okay. This is about the waveform of output voltage across RL, right? Thank you.